All right, hello everyone, this is Mr. Crozier. I want to give you some help on a few of these problems on our second practice test. Problem number one, pretty basic. You are just doing left Riemann sums, right Riemann sums, trapezoids with this data in the table. So use the intervals as shown. On number two, average value. Remember, if you're going from 1.5 to 10, you're going to divide this integral by 8.5. This value out here is 1 over b minus a. On the next one down here, this is one you should definitely want to be able to do by hand. We integrate it, fundamental theorem of calculus. On number four, 4 right Riemann sums. Here's my 1, 2, 3, 4 points. And notice this last Riemann sum has no area to it because from the right, it's at the ground. So we have 1, 2, 3 rectangles added up. Number 5, definite integral, just a calculator problem. Can you type it in, get the right answer? Number 6, we're going to start here at acceleration. Then we're going to integrate back to velocity. We can use this piece of data right here that says at 2 seconds, the velocity is 42. So right here, I am inputting v of 2 is 42. Which will give me the c value, which now gives me an equation for velocity. On number 7, we have to do the same kind of logic, but we're going to go from acceleration to velocity to a position function. And the trick on this one is that the ball is thrown from the ground, so the height right here on the position function is 0. Right Riemann sums, know how to do this with and without a calculator. With a calculator, you can punch it in and get this answer. Without a calculator, you would just have to write this down. So you'd have to write down this formula and not evaluate it. On number 9, to find the exact value, just make sure you pull this pi out to the front because it is a constant. So we could just do the integral without the pi, then put the pi back in. Classic net change problem. I am starting at 400 and I am subtracting the net change, which is the amount that it leaks. Number 11. This is the same exact problem. This is the starting value minus the net change. However, in this case, the net change is coming from a table. In this case, the net change is coming from an interval. Number 12, sketch the function. You will see what looks to be a trapezoid, but be very careful. This right here does not go all the way down, so it's really a rectangle with a trapezoid sitting on top of it. So you have to do the area of the trapezoid, then the rectangle. Number 13, a differential equation, which is speed, and we're looking for the negative area, which is below it. Graph it, find the zeros, the a and the b, and you can integrate it over that area. So find the intersections by using your calculator. 14, it just says marginal profit, which means the change in profit, integration. Number 5 is an indefinite integral. We don't have inputs, so we just integrate it, put on the c. For calculator, displacement. Your calculator does displacement from 0 to 5 of the function. If you want it to do the distance, well, then you have to do the absolute value. And down on number 17, you're going to have to do that by hand. Displacement, this area is positive right here. This area is negative there. Positive plus negative is there. On this one, I have to do both positives. I have to do distance, so I want positive, positive, absolute value. Up here, your calculator does it. Down here, you have to do it by hand. Number 18, find the area in quadrant 1. Well, if you graph it, you will see it's a quadratic that goes up into quadrant number 1 from A to B. Again, get those points by getting the zeros from your calculator. Trapezoid rule is 1/2 times the dy, and remember, or the dx, sorry, and the dx is b minus a divided by n. So these are my values here, 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 here. And this is my formula. Now look what I did here. This value here is ln of 3. I didn't estimate that, I just wrote that there. And this one, it goes here. and here in this last one's ln of 10. Don't estimate it if you don't have to. Just leave it like that. It's a little bit shorter. And now when I write it, I have 1/2 times delta x. The first one, 2 of the second, 2 of the third, 2 of the fourth, and the last one. On the last one, we have a coffee pot that starts at 70, drops to 40. And if I integrate that and divide it by 12, I get the average value. So if you want the average value of a function, remember, any function you have, if you integrate it and then divide it by b minus a, that gives you the average. And the average, if you do all this computation, it comes out to 51.583, and 51 degrees is right here, and that definitely appears to be an average temperature. It's right in the middle of our list. So it appears it could be a good average. All right, hope this helps for your test.